This video is about binomial distribution. A polygraph test is used to determine whether people are telling the truth or not, but it is not completely accurate. When a person tells the truth, they have a 20% chance of failing the test. Each test outcome is independent of any previous test outcome. 10 people take a polygraph test, and all 10 tell the truth. A. Calculate the expected number of people who will pass this polygraph test. Since there are only 2 outcomes in this event, we can use binomial distribution. For probability of passing test equals 0.8. Probability of failing the test is 0.2. So for question A, X follows binomial distribution with the number of trials 10, 0.8 for the probability of passing the test. E of X equals N times P means 10 times 0.8 equals 8. B. Calculate the probability that exactly 4 people will fail this polygraph test. Y follows binomial distribution with 10. Probability of failing the test is 0.2. We are looking for probability of Y equals 4. Let's go to calculator. Go to menu, statistics, go to 5 distribution. We are looking for binomial PDF, so go to A. N is 10. Probability of desired result is 0.2. X value is 4. Answer is 0.0881. Let's go to C. Determine the probability that fewer than 7 people will pass this polygraph test. Probability of passing this test is 0.8. X follows binomial distribution 10, 0.8. We are looking for probability of X less than 7, which is the probability of X less than or equal to 6. Less than less. 6 is a upper bound. 0 is a lower bound. Go to menu 6, 5. Upper arrow button. B. Binom CDF. N is 10. Probability is 0.8. Lower bound is 0. Upper bound is 6. Enter, enter. Answer is 0.121. Let's go to D. Determine the probability that more than 6 people will fail this polygraph test. We already defined Y follows binomial distribution with 10, 0.2. Keywords is fail this polygraph test. We are looking for probability of y greater than 6, which is the probability of y greater than or equal to 7. Lower bound is 7, upper bound is 10 or really big number. N is 10. Probability is 0.2. Lower bound is 7. Upper bound is 10. Enter, enter. Answer is 0.000864. You can change this 10 into big number. Upper bound, let's do nines. Use 4 nines. Enter, enter. See, you got the same answer. Let's go to guided practice 2. 2 fair 4-sided dice, 1 red and 1 green are thrown. For each die, the faces are labeled 1, 2, 3, 4. The score for each die is the number which lands face down. List the pair of scores that give a sum of 6. Let's list all the outcomes. 1, 2, 3, 4. 1, 2, 3, 4. This is green. This is red. Let's add this number together. Altogether, we have 16 outcomes. Sum 6. We have 3. So we get 4, 2, 3, 3, 2, 4. The probability distribution for the sum of the scores on the 2 dice is shown below. Find the value of PQR. P equals, check 2. Only have 1, 2. So answer is 1/16. For Q, there are 2 3s. So answer is 2/16. R equals 2 7s. So R equals 2/16. Let's go to B. Fred plays a game. He throws 2 fair 4-sided dice 4 times. He wins a prize if the sum is 5 on 3 or more thrown. Find the probability that Fred wins a prize. For this event, since we only have 2 outcomes, the sum of the score is 5 or not 5. We already figured out the probability that the sum is 5 equals 4/16. It's given here. Equals 1/4. Let's define random variable x follows binomial distribution with 4, 1/4. We are looking for probability of x greater than or equal to 3. Binomial CDF, n equals 4. probability equals 1 divided by 4. Lower bound is 3. Upper bound is 4. Or you can put a really big number here. You will get the same answer. Answer is 0.0508.